Is it better? Okay.
Okay, so welcome back everybody for second half of today. I hope you enjoyed our demonstrations and lunch as well. So we now start with a presentation on the third aspect of the FascinatE project, which is all about immersive media delivery. There will be a presentation by Mr. Jean-François Mac from Alcatel-Lucent Bell Labs in Antwerp, and myself as well for a couple of slides. After that, we have a presentation on audio rendering by Mr. Holger Kropp from Technicolor in Hanover, and again our own Rob Oldfield from Salford University. And we end today's presentation session with a story about gesture-based interaction from Mr. Javier Ruiz Hidalgo from UPC in Barcelona. And after that, we have yet another hour where you can chat with the guys who are working on this project, see a bit more of the demonstrations, ask questions, whatever. And there will be additionally some drinks, I guess, in the hallway for you to enjoy. So, Mr. Jeff, please go ahead.
Thank you, Omar, for the introduction. So you know that FascinatE is all about redefining the TV experience. And if you look back in time and you watch this scene of a family watching TV 60 years from now, and the kid asks Dad, okay, Dad, what will TV look like in 2013? And the dad for sure would reply, 2013, well, it's going to be completely different. And okay, we've known transition from old analog to digital, from 2D to 3D, but essentially the TV experience itself is more or less the same as it has ever been. So question, what has changed? And actually it could be completely different. I mean, if you think you've seen a lot of demos about football, if for the ones of you who were here this morning, and if you were watching yesterday Aston Villa, Manchester City, I guess it would have been nice to basically be able to just look at any point in the panorama, just live, do in a kind of replays, and the ability to zoom in, zoom out, maybe just see some fancy stuff happening in the audience, although the resolution here is not so good to do that yet. But the point is that clearly there is a demand for more interaction, more personalization in the TV experience. And basically what we propose in FascinatE is to solve that by doing this format agnostic, this full scene capturing idea where we capture a lot of data and then we are able basically to choose whatever we want from that scene in real time. So a few trends which are accompanying that is that, of course, people are now we used to have that kind of speech already 3 years ago, but that was before some of the trends we are showing now, because now people are really getting used to tablets. I mean, you have this application of EVS CCAS. I don't know if you know that, but that's something that EVS, which is normally more in the broadcasting area, is also developing to really touch the end users and really give them an application so that they can access different types of feeds from sport events. Also, 3 years ago when this project started, nobody would know about spherical video or immersive or interactive video. People would know Google Street View, but that was it. I mean, now you have some concerts which are streamed over the web in 360 video. So I think people are getting used more and more to, or are expecting more and more from the media and the video industry. And HK has made some splashes at the last IBC edition with their 8K resolutions, also more quality. So all in all, we have more demand for personalization, for interactivity, and for high quality. And that's basically what we try to solve with this format agnostic approach in FascinatE. So if now I'm in the place of the service provider, I am, for instance, BT, I also need to be a format agnostic service provider, which means that I have on my left hand this huge set of content. I have lots of high definition feeds, panoramic videos, nice audio feeds. And on at the other side of the chain, I have lots of different end users. Some of them have HDTV, maybe 4K TV, some are on tablets, low bandwidth, high bandwidth. And if you are BT or France Telecom or whomever in the middle, we basically need to reconnect those two ends. So you need to provide good network, you need to be scalable to the interactivity demands, to the different type of interfaces, and also to the novel media representation that are linked to these new type of contents. So if we now try to see how that maps to the traditional TV model, well, it has already been that it was assuming that you would have some kind of production format. So you would start from from the camera or from some archive content. And then you would basically create a production format out of that. And the output of that is some TV channels or streams or clips. And those clips are basically delivered to your end users. And this is working because you have these content sharing properties, which makes that people are watching the same content under the same format and often at the same times or around the same time. And that's why broadcasting is working. So think about the DVB-T, DVB-S, IPTV multicast has been also deployed in telco systems. And you could also say that unicast and video on demand is working because people can anticipate to a great extent what user will want in terms of a set of well-defined content, hot content, and also around a somehow well-defined period of time. So it's not completely wild, these demands for video on demand. So that allows you to basically prepare your content delivery networks also correctly. But of course, that if you know, we say that we leave the end user decide on the format. The end user can basically start making interaction, saying, I want it live, I want it on demand, I want it anytime, I want you to adapt it to my HDTV, to my mobile phone, I want to choose my viewpoints. And if the format needs to be changed based on those requests, it would mean that you need to feed all those requests to the production. And also then you have a problem because production can't scale to this high dynamicity of end user demands. And the other problem would be that these content sharing properties would be lost because you're not sending the same thing to the people anymore. So that for sure does not fit. So the idea would be to say, okay, if you want to have format agnostic content, then do the formatting at the other side of the chain. So you could say, I'm going to have a setup where I do format agnostic production. That's what I ship to my delivery network. And then the formatting is happening close to the end users. So that also means that you need more processing on behalf of your end nodes, either at the end nodes or close to them. But still, you have the fact that the data that you ship, it's not one HD stream, but it's much more. It's basically all your data stream, it's all your cameras, all your ambisonic audio capturing system, so that you make sure that you will ship enough data to the end user so that he can make his selection. So we have those two issues, more data and also more processing for the end user. So just think about how much data for FascinatE. I remember when we started the project, after a few months, we had this was the very first preview we had from Fraunhofer HHI, and I like it because it really shows that the Omnicam is really made of 6 HD cameras. Next to that, there were also 4 HD broadcasts. There was a 3D laser scan that Graham showed this morning. There were some high dynamic range, also a whole range of audio devices. So we were like, great, we'll have a Chelsea game in the highest quality you could imagine. So let's give us the full game on the hard disk. And the first answer from Oliver Schreer from HHI, no, you will only get 8 minutes. That's all you get. Why? Yeah, because you need 1 terabyte of content for just those 8 minutes. So that means a rate of around 16 gigabits per second uncompressed data. That although we knew it was a lot of data, it was still a shock to see those numbers. So how do we deal with that? How do we do that? That if we start from this format agnostic capturing, we have to ingest these 16 gigabits per second of data. That's the challenge on the one hand. On the other hand, we have all those different devices. Then it might be like this nice theater at the time lab in Berlin at the Fraunhofer. It could be HGTV, it could be thin clients on the go. And basically, if you are in this mode of I'm shipping everything I capture to this very nice immersive system, what you need essentially is coding. I mean, you can easily get from this 16 gigabit per second to a few hundreds of megabits per second. That's okay. But still, you will not be able to ship this to an HGTV system or to a tablet for sure. So if you look at the bandwidth, say 10 megabits per second or half a megabit per second for tablets, you need something else in between. And that in between, one of the first solutions is to start segmenting and cutting the content in multiple pieces so that you are not forced to just ship everything to the end device. So once you start doing this segmentation, so you can basically have a finer granularity in your data, you can also start adapting the transport and making sure that among all these data which are pushed by your system at the source, you can only send what is needed to the clients. Still, I mean, if it's segmented content, if it needs to be rendered, you still expect a lot of processing from your end device. And you may know that on a smartphone, on a tablet, I mean, this is a scarce resource. So an idea would also be that you can actually do the rendering and actually change the data, prepare it on behalf of your tablet. So basically, you see that there are these three types of operation that may depend on the type of client you are serving and also your delivery conditions. And the way to look at it is that you could see that you have a range of devices with a difference in processing capabilities. And if you have devices which have less processing capabilities, you can basically compensate by more processing in the network. So you have this kind of balance between what is done where in your system. And so these three topics will shape the structure of the rest of this presentation. So let's start with coding. So I've heard that there were audio guys in the room, so I've prepared a one-slide tutorial on video coding. No offense, if it's really too basic, just let me know, I'll skip this. So just to go quick on this, so we have video, this is a sequence of array pixels, so we have numbers, and we want to compress that, so use the redundancy that we have in the contents. So usually how it's done in current standards, these things might change, like we discussed over lunchtime. Meaning that you take small units of, say, 16 by 16 pixels and you start coding them in raster scan order. And basically, for each time you code, you look back at what has already been coded and you try to predict these things based on what has been already coded. So that's basic compression ID. And you have two ways of doing that. You can either do that based on the information which was in the same picture or based on the information which was encoded in previous pictures, because also you have a lot of redundancies in consecutive images. So actually I lied, it's a two-slide tutorial on video coding. So as I said, you can do a prediction based on intra or on inter prediction. And what actually the encoders encode, it's the prediction, so how each microblock is predicted from the past, and then the delta, what was the difference between the prediction, how good you were compared to the video signal. And basically what you end up with is a structure of what's called I, P, and sometimes B frames, where an I frame is something that is coded only intra, so not referring to previous picture, and the P frames are basically always looking in the past to make the prediction. So that's just to give you a rough idea of how the data is organized. And the focus of most of the coding standards has always been, as far as I know, on trying to balance the compression performance against the picture distortion. That's the main criteria. And if you look at those curves, you start here with, I think, MPEG-2. So that's basically, that shows you what quality you can get on the y-axis for the bitrate on the x-axis. And so the more you move across time, you go from MPEG-2 to H.263 to H.264 to HEVC, which is the latest standard. And each time you see that for the same bitrate, you get either better quality, or for a given quality, you can compress at a much smaller bitrate. So that has been always the focus of those codecs, which is not really the only things we want for FascinatE. Why is that? Because in FascinatE, what we would like to get is the ability to, okay, from the server side, to compress as much as possible. That's normal. But on the client, I'd like to be able to just decode this small part of the contents. But if I've compressed everything as a single block, the problem is that this region here is compressed based on all the things around it. So I cannot just get this small part of the stream and decode it, because I will miss some references out of that region. So basically what I have is some kinds of trade-off between the compression and my ability to interactively access only sub part of my contents. So that's also called the random access property. So it's only the ability to only decode some parts of the data and just get rid of the rest without even looking at it. So there is a notion of temporal random access, and that's basically what usually determines the zapping delays in digital TV systems. So if you go back to this IPB type of coding, so this might be, for instance, a TV channel you want to access to join when you are switching zapping in your digital TV system, and suppose that at some point in time you zap, and that predicted frame here is the first one you get. Basically, you cannot decode that because it refers to frame which you have not received. They were basically sent in the past and you were not there. So we have to wait until the first iframe to start decoding. So this latency here is the random access. You could solve that by just encoding everything as iframes, but of course then your compression would be much worse. So again, there is this trade-off between how nicely I can access a stream and how good I can compress it. And that things also happen for spatial random access. And that's what we are after in FascinatE. So the idea here is that we would start with this panorama. We encode it in such a way that basically when I start from my compressed video, if I have clients which makes different requests to that file, I can basically get access to only a subset of decodable units. So you could have two extremes. One would be the monolithic coding. I code everything as a single block, and as a result of which, whatever I ask, I will always get everything to my end device. The other way would be to say, no, I want to keep each pixel accessible. But in that case, you cannot compress at all, but you can really, of course, get each pixel, but you have no compression. So unfortunately, there is no off-the-shelf solution from coding standards to solve that in a very balanced way. So the best we can come up with is basically to come to the idea of tiling. So basically, we segment our content into independent tiles, and each of them becomes an independently decodable unit. So the way we do that is that we start from the panorama, we choose a tiling scheme, and we split the content in those tiles. And basically, each square here means that this part of the content will be encoded as a individual stream. So it's nice because I can only decode that small portion, but it also means that if I had some elements here which were very similar to the ones here, I cannot use that redundancy in my compression scheme. So I have a penalty in terms of compression. So what we did in some studies was to try, okay, but to what granularity should you tile this content? And so again, balancing the two extremes, you could start from an idea where you say, I don't do any tiling, or I could start by a very coarse tiling and make it finer and finer and finer. On the other hand, if I have a client which makes, say, this, so this represents the full panorama, this represents a request. The nice thing is that if I have a very fine tiling, I can basically approximate my request very finely. You can see here that if I have very small tiles, I can approach the region I ask very, very finely. While if I have very coarse segmentation, also I will send much more content than what the end user actually requires. In the worst case, if I don't do any tiling, whatever I ask, I will receive everything. So there I have a huge waste of resources. So I have this balance that the more I tile, the higher the penalty will be on my server, but the lower bandwidth I will require on my end clients. So that's a study we had done trying to see, okay, what's the penalty between server and interactive clients point of view. So here you can see that I have those rate distortion curves starting from the finest tile to the no tiling at all, so one by one. And you can see that for a given quality, if I have no tiling, or if I impose a very fine tiling, I have more or less a ratio of 2. So I mean, the penalty of tiling is really existent. But on the other hand, if I look at how much bitrate I need to provision on my client side, then you also see that tiling really helps hugely, even more proportionally than it does on the server side. So that's the kind of trade-off we are after in this system. Then, okay, that's all nice. We have these tiles, but how do we transport them? Because the whole point of tiling is that you don't want to transport everything from one end to the other, but that you want to filter in the middle. Somehow we developed, we had a lot of discussion in that when the project started, whether we should go from a clean slate approach or trying to go more into a solution which can nicely build over current web streaming technologies. And we say, okay, if we can choose, let's do both. Basically, we have a way here where we say, suppose I'm in the feed of a service provider. I have full access on my network, which means that I can put basically any elements I want in my system. So in that case, I could really start more from a clean slate approach and try to optimize everything as much as I can in my network. At the other extreme, suppose now you are a service provider over the internet. You are a Google, for instance, so you don't have access to the nodes which are between the server and the client. So then you have to compose with whatever the internet is, knowing that it's not always the best bandwidth, that it's only best effort, that you can have latency. And let's see what we can do with that. So now in this talk, I will now focus on the managed aspects in the rest of that presentation from my side, and then Omar will continue on the internet file-based delivery aspects later on. So what can a network operator do? That's something we already discussed. So there was the segmentation aspect, there was the adaptive transport, making sure you can nicely filter the tiles, And then also even the rendering operation, so really processing content on behalf of the end device. So let's start with that one. So the idea, and that's actually one of the demo we have today. If you are interested, just come starting at 4 when the demo resumes. The idea was to say, okay, now if you look at how interactive streaming is happening on the internet, the way they do it is that they would take the panorama, they would shrink it to a very small resolution so that it can be sent to you. You would receive the whole panorama and you would be able to browse into it. But if I would start zooming into it, then you see that you have a very poor resolution. So we try to say, okay, let's do the complete opposite and try to send only the pixels that are required by an end device at any point in time. That means that we have here a setup where we have a thin client approach. The client device is always expecting to receive a fully pre-rendered stream at the resolution that matches its display, which means that when I'm navigating on the device, I'm actually sending to the network my interactive comments. That network node is maintaining the state of where I am in the panorama, does the reframing, does the rendering, compress the data and ship it back to me. And actually, the demo shows that this whole interactive loop can happen in real time. And in the current demo, we have something like four clients. Of course, we could move it to 16, a bit more, but not millions of clients on a single device. So there is a notion of locality that this rendering proxy should be quite close to your end device, and you should have multiple of them spread in your networks. So essentially, it's nice because somehow we solved a kind of perfect random access. I only ship the pixel I want to my end device. But since I said that this server cannot be the central server close to your source, we have just pushed the problem one hop further because I still need to feed that local proxy with the content. So the problem just moves away, but is just there behind the door. So for that scalable streaming, the idea was to say, okay, if I now look at all those styles that I have, so I start here from my panorama, I start making a downscale version, I start to segment it like I presented before, and basically we have a whole set of independent segments that are available to be pushed to the proxies I've just mentioned. The idea is now that if I start publishing that to my network, I could start from that point of view saying I'm the ingest, I'm preparing network, I'm pushing that to the network. On the other hand, you have the proxies which are working on behalf of client, and they just would like to pull the content that they need, not less, but also not more. They don't want to receive everything. So how, between this push from the ingest and that pull from the proxy, how do you mix the two? And the idea there was to say, well, we would like to somehow monitor how popular a tile is. So meaning that if you have a few tiles, for instance, which would be always following the ball, there is a high chance that all of the proxies would like to have that. So it would be stupid to just have a session for those tiles, one-to-one from the ingest to the proxy. So that would be more efficient to just broadcast them or multicast them. On the other hand, there might be some tiles which are somewhere in the sky or in the audience where nothing fancy is happening. That would be a waste of resource to also multicast and broadcast those ones. So, So there is this idea of differentiating between popular and unpopular content. And in that case, to say the things which are asked by many people, I ship it on multicast in such a way that I only have to ship it once over multicast, no matter how many end clients request it. But I also don't want to waste my multicast resource, so the less popular content will be sent over unicast. And of course, I would like to be able to dynamically switch and reevaluate what's popular and not popular. And that's basically what the second demo that we have today shows. So I guess I will conclude here for the part on managed network. I guess we can take questions at the end of this talk and of course also during the demo session. So now I will hand over to Omar, who will now focus more on the internet-based approach for basically also reusing the same type of segmentation concepts. Omar? Yeah. Right.
So now I'm faced with the daunting task to do time management, present, and do questions afterwards. Let's see if I manage. So, as my colleague Jeff explained, within the delivery part of FascinatE, we basically investigated two tracks. One was really focusing on this managed approach, and the other one is really looking at how is media delivered over today's internet, and how can we use those technologies when we want to deliver this layered scene, audio-visual content towards the devices of today and tomorrow. And if you talk about the internet, you're basically talking about video over the internet. That's today referred to as over the top, so that's what the three letters OTT mean. But if you look back several years and see how media delivery over the internet started out, it started out with what we now call HTTP, the Hypertext Transfer Protocol. And it started out as a mechanism to download web pages over the internet. And I just Googled some of the web pages that we know that are so familiar today, but just to see how they started out, on the left we have eBay and on the right we have Amazon. So you could say things changed already quite a bit there. But as soon as people started looking at actual video over the internet, they noticed that HTTP at that point might not be a very good solution, because HTTP is basically for download. And when you download something, you need to do a full transfer of the file or content that you want to see before you can start playing it back. And you can imagine that for live video transmissions over the internet, this is just not usable. But also for video on demand, think about the huge video files you would have just a couple of years ago when your computer storage would still be limited, when you would not have devices with, let's say, 4 to 8 gigabyte SD cards. So that's when streaming came by, video streaming. And streaming allows you to basically play back the content while it is being received. And there's a very nice image coming from a article by Frans Kozernik in an EBU magazine, where he compares it to saying download is like first filling your glass with water, then drinking it, and streaming is like drinking straight from the bottle. And I think it's a very apt metaphor that you can use. There is, by the way, a third method which is called progressive download, and there you actually start downloading parts of the content and use those parts that you downloaded in already to play back the content. And this is actually a very interesting approach, because when you look at video streaming, it seems great. First of all, it does not occupy this space on your device. So for a while, when your storage capacity on your devices was limited, this was ideal. It will only use the network bandwidth it needs. You basically request a certain bandwidth when you start streaming, and you are guaranteed that you will not overshoot there. And we've seen some very popular examples. I think the protocol, so the technology that's being used to transfer video over such network that has been used a lot is called RTP, so real-time transport protocol, and there is an associated protocol in order to control this transfer. Another one, even more popular, is probably Flash, the real-time media protocol, which has been popularized by Adobe, and you've had it in all your browsers and on most of your devices. However, it's disappearing. Video streaming in this way seems to disappear because there is an issue with video delivery over the plain internet, and that is, actually it's very basic, is that most of these protocols, they do not arrive at your house. They do not arrive through your home gateway, which is the box you get from your cable or service provider. They do not go through the firewalls of companies. So that's going to be an issue if you want to do large-scale video streaming. And the second part is that internet is, as Jeff explained justly, it's a best effort network. So you don't actually know what the bandwidth is going to be, which means that if you do video streaming, and even if you agree on a certain bandwidth before you start streaming, once that bandwidth changes, you are in problem. You will see freezes, you will see that the video is stuttering. So that's not good. So what happened then? People started looking, and actually Apple was the first one to really look into this. They said, well, this progressive download, it's quite nice, but it needs some additional features. Can we change that idea of progressive download of media in such a way that it basically resembles streaming? And that's what they did. So what the idea behind HTTP adaptive streaming is that you take a video file, which could be video packets coming in from a live broadcast, and you segment it into very short files. And then you start downloading these short files. And you make sure that you just have enough of the content available to start displaying it. Well, that's already very handy, of course. But the next interesting trick, and here I will need the pointer, see if it works. There we have it. So over time, this is where we chop up the files, create segments. But there's a second thing we do. We create multiple qualities, multiple encodings of each stream. And because we have those qualities and those segments, when you look at the bandwidth you have available in a given video streaming session over the internet, you can actually switch from quality to quality. And that is what you see here. So there might be a time when you have a low bandwidth available. Well, let's start with these low quality stream first. And as soon as the client, an end device, observes that the available bandwidth is actually higher than you started out with initially, you have the option to switch to higher qualities. And in this way, you actually adapt your video streaming or video transmission solution to the bandwidth that is available over the internet. So this is a technology that's becoming very popular, and you can certainly see this in most of your devices like tablets and like smart TVs. And there are two parts that this technology is really interesting. On the one hand, because you're using HTTP, it's completely reusable over today's internet infrastructure. You have web caches, you have all the infrastructure available to deliver content segments over HTTP. So no need to create new infrastructure. So if you look at how this adaptive streaming is implemented, we have the part, you have a source material, you encode it into these various qualities, you describe all this information into, let's say, an EPG, metadata, just a file saying, I have these different qualities available and these are the segments. And all the rest, this here, where you actually need to store the files for delivery, that's going to be usable over any of today's so-called content delivery networks. Very handy. And secondly, if you look what needs to be implemented on your device, then you will see that this is already there, because as soon as you have a browser which can access web pages, it's basically the same technology. You have technology to display video and audio. So the only thing you need is some additional control software which requests all the segments in time. So that's very minimal. This is much easier to implement than, for example, any change of a video codec. That's going to be a huge thing. And as said, if you look at what is required on the server side, it's just storing those segments in a web cache. Okay, so this technology looks nice, but how is this usable for what we want to achieve here? Well, as Jeff explained, for these high-resolution video, we are going to segment not only in time, but also in space. We create spatial segments in order to have spatial random access. And actually, if you start out with this layered scene description that our colleague from the BBC, Graham, mentioned earlier, we can start already there to see if we can adapt this to this adaptive streaming. So assuming that, and I guess I'm in front of this part, so assuming you have your layered scene, you have the omnicam, you have some broadcast cams, all of that. The first thing you can actually do is say, let's make this particular camera source available in multiple resolutions. So we would have the original resolution, say 7K by 2K, but we will also create lower resolutions, for example, HD and something in between. And the next thing we do, each of those images we start to spatially segment. So we say a certain grid, 2 by 2, 4 by 4, and each of those grids is associated with a number of tiles. Until then, nothing different from what Jeff just explained. But if you take such a tile and you create multiple encodings for each of those tiles, and you create time segments, this is exactly what HTTP adaptive streaming is. So we can associate to each of these tiles an HTTP adaptive stream, which means that streaming this information over the internet basically amounts to having several of those streams available, and the main thing you need to do is combine all of those tiles together in order to get the view that you want to see. So that's basically one of the demos we have set up as well. So this is the part Jeff explained. It's the content segmentation, the tiling part. And then what comes out of here can be stored in a regular HTTP server. So we have some here offline, but you could, if you want, push this directly to a content delivery network. And then all of those spatial segments are sent to a part where they are received and combined into the image that we want to see. And just for the fun of it, we use some second screen ID to navigate through this. You could navigate with different ways, for example, gesture-based interaction, but you could also navigate using your tablet. Now, the nice part of this type of transport is that it allows you to easily combine multiple sources. For example, if the layered scene representation also contains broadcast cameras, we could, of course, aim for combining those images into the overall panoramic video. But why not send it directly to the second screen? That's very easy because the way this content is related to each other is just described in this metadata file. It's typically called a manifest file. There you can describe all of these relations and basically request all of the content that you need and put it on the device you want it to have. So this is yet another way where we demonstrate how this content can be delivered over today's networks as well as over the ones of tomorrow. So in conclusion, part of the FascinatE project has been focused at looking to solutions for scalable content representations and the transport of those representations. We did consider the impact of video coding. However, as mentioned in the beginning, that was not the focus of the project. Instead, we really looked at how do we need to optimize the processing of media, how do we need to optimize the transport, such that it can fit to the several networks that we have available right now. And how we will continue? Well, obviously, like all of the other partners, we will contribute to the final demo, which will take place end of May at MediaCityUK as well. And beyond Fascinate, many things could happen. For example, it might even be possible to create with this type of technology services that give you the impression that it's even better to not be at the event than to be at the event, because you can combine all of this information with statisticals, new views, maybe make sure that you are at the event in your own living room. So all of this is still ideas that we have, and where we still want to see how transmission needs to be adapted in order to do this. So thank you for your attention, and let me ask if there are any questions from the room.